Hello, welcome to tutorial session 4, our last session for assignment number 2, problem 4. Um, so the question is given us the old machine was bought 5 years ago with $4,000 and it has been partially depreciated. Now it can be sold with $2,500, but it could be used for another 3 more years. So if we continue to use this old machine for another 3 years, it can be sold with a salvage value with $100. Um, and if we decided to continue to using this old machine, every year it costs $8,000 for operating and maintenance. The new machine, in this case, if you want to purchase a new machine to replace the old machine, will cost us $14,000 to replace. And it has been already calculated that this new machine has expected economic life of 3 years. So let me just highlight that of economic life of 3 years. And it has no salvage value at the end of the third year. And maintenance for this equipment, new machine is given a $2,000 for maintenance cost for the first year and $3,000 for the next 2 years. Assume the interest rate is 15%. The question is asking what is the depreciation rate of the old machine, and should the old machine to be replaced? So in this case, so we have our defender. So that's the old machine. Okay. So now if I try to fill this table, now this machine worth of $2,500. So the question that's given in the question. Now, if we calculate first year, second year, third year, so if we decide to keep the defender for 3 more years, specifically, what is the EAC per year? We try to calculate, and also the question gives that for each year, the annual operating and the maintenance cost for the old machine is $8,000. So here is $8,000. Okay. So really, what we're missing is the book value for this year 1, 2, 3, and based on that, we can calculate our EAC capital. So in order to find the book value, we need to find the depreciation rate. So that's basically what the question is asking for the first part of the question. So depreciation, in this case, for the old machine, will be, if we continue using the machine for 3 more years, that will be the salvage value at the end of the third year, which will be $100, and then the current price, which is $2,500, and this will give us 0.658, so which is 65.8% depreciation rate. Okay, so based on this, our book value 0, book value 1, book value 1, book value 2, and book value 3 can be calculated as 2,500 times 1 minus d. So second one will be 2,500 minus times 1 minus d squared power of 2, and then the third year will be 1 minus d power of 3, right? So all this value here will help us to fill the information in this column. And once we find out the value here, we can then use our EAC capital equation to calculate our EAC value. So just to refresh the memory, our EAC will be equal to our the purchase price minus our salvage price and times A over P, the interest rate, and plus I times S, right? So give an example. So EAC1, for example, will be 25, right? So let's see, this value here after we calculate is 855. So that will be minus 855, right? And times A over P. So interest rate is 15%. And then year one, right? So we decide to keep the Defender for 1 more year. And then times 15% times 855. Okay. So this is our Defender. And then after we calculate the EAC capital, then we can sum column 1 and column 2. So this column will be equal to column 1 plus column 2, right? So then we can get our EAC Defender, right? I, where I equals to 1, 2, 3. So this is our the calculation for the Defender. Now let's take a look at the Challenger in this case. So the Challenger will basically be the new machine. And it's already calculated that the third year is the machine's economic life. Okay, as we have highlighted before here, 3 years. Okay, so for that we need to perform similar type of calculation. Our EAC Challenger will be equal to EAC capital plus EAC operating cost, right? So our EAC capital for the third year, capital, okay, so that will be equal to so 14,000. So that's our purchase price times the conversion factor 3, because the question says after 3 years of use, the new machine will have no salvage value here. So this will give us $6,131, $72 per year. And then we can continue calculating our operating cost, right? EAC is 3 years. So in this case, we have our $2,000 for the first year, the maintenance $2,000 for the first year, and then we have $3,000 for the next 2 years. If we look at the cash flow diagram, let me just draw the cash flow diagram here really quick. So we will have, this is just for operating costs for the Challenger. So we will have $2,000, right? And then we have $3,000 and $3,000. In order to calculate the EAC, we can convert all these cash flows into present worth and then spread it over 3 years period of time. So let's just convert those values back to its present worth. So we can divide by 1.15 because 15% is our interest rate. So this is 1.15 power of 2 plus 3,000 divided by 1.15 power of 3. After we convert this, then we can spread the present worth over 3 years. So basically, we know P looking for annuity, 15% of its interest, and then we have 3 years. So here we calculate, we get our EAC operating and we get our EAC capital. So then we sum these two together, then we can get our EAC Challenger. So our EAC Challenger in total will be, in this case, 8,750. Okay, so this is our EAC for challengers. Now the next step, after we calculate for both defender and challenger, we need to compare them. Okay, compare EAC challenger and the EAC defender. So here's the example. If EAC challenger is less than EAC defender for a given year, then we need to replace using the challenger at the given year. Okay, so that's the logic for solving problem number 4. Just to refresh your memory, on the left side here, we calculate the scenario for defender, the old machines. We calculate the EAC based on operating cost and the capital cost. On the right side, we're calculating the EAC for the challenger. And then we compare the EAC challenger and the EAC defender to find if we need to replace the old machine with a new machine at a given year. Okay, so that's the logic for solving problem number 4. Thanks for watching.